going into our discussion on Chapter 5. We are working with isosceles and equilateral triangles today. All right, so let's start off with some vocabulary with the anatomy of an isosceles triangle. First thing is, as we talked the other day, the sides that are congruent are each called a leg. The point where the two legs come together, that is called the vertex. Then, when we look at the triangle, the side opposite of the vertex, so if you come straight down, the side opposite of that vertex, it is called the base. So therefore, then this angle and this angle is called the base angles. Okay, so we have vertex. The two sides that are congruent are called the legs. And then we have the base, and the base has two base angles as well. First theorem that we have with isosceles triangles, if two legs of a triangle are congruent, in other words, isosceles, then the base angles are congruent. So what does that mean? Well, since I have these two sides being congruent, then I know this angle and this angle are congruent as well. So how do we use that? Well, we would just take these two values, set them equal to each other, and we simply solve. So 2x is equal to, we minus the 40, so x would equal 11. Then we know that if we plug that back in, 2 times 11 is 22, plus 40 is 62. And again, you will notice those two angles are exactly the same. Now over here on this side, we know the vertex angle. So this is the vertex angle is 76 degrees. So that would make x and y be the base. So that x is equal to that y. So what that means then is that when we look at that equation, we know that x plus y plus 76 would equal 180 degrees. So then we know that x and y are the same, so by substitution, we can say x plus 76 is 180. So 2x, I'm going to subtract the 76, would equal 104. We divide that by the 2, and that gives us 52 degrees for each one of those base angles. So x is 52, and y would be 52. Because remember, the base angles of an isosceles triangle are congruent. We also have the converse of the base angles, which simply says if two angles of a triangle are congruent, then the legs of the triangle are congruent. So when we look here, here's my base angle. So the legs of the triangle, opposite of those base angles, those two values would have to be the same. So we would take and we'd say 2x plus 28 is equal to 8. So then that would give me 2x equals a negative 20. Divide that by 2, x equals a negative 10. And if we plug that in, 2 times negative 10 is a negative 20. Plus 28 would give us a value of 8. So that is the base angle theorem and the converse. Okay, now it also brings about a corollary. A corollary is simply a theorem that we have that we can extend into further pieces. So here is the base angles theorem corollary, and that is if a triangle is equilateral. So remember, equilateral means all sides equal. So if a triangle is equilateral, then it is also equiangular. All angles equal. Likewise, we have the converse base angles theorem corollary. If a triangle is equiangular, all angles equal, then it's also equilateral. So what we would know, like on this one, since this one side is 5, then that would tell me that all of the sides are 5. In the first one, since I know all the sides have their tick mark, then I know angle Q, angle P, and angle R would also all be equal. So how do we use this? Well, let's go through and see if we can figure out the measurements of all of these different things. So when we start off here, okay, we take a look at these two, and we know the first thing I look at is I'm going to try and find the values of x, y, and z. Now, you kind of start off and you look and see, okay, is there a measurement we know? Well, the first thing I know is since the three angles in this triangle on the top are equal, then that tells me that all three of those sides also have to be equal. So therefore, since this side is 4, we know y also has to be 4. Okay? Now, since all three angles are equal, we also know that all of those angles measure 60 degrees. Because remember, we talked about that a couple days ago, that in an equilateral triangle, all the angles would add up to 180. So 180 divided by 3 equal angles would tell me that each angle is 60 degrees. Then I can use the fact of a linear pair. So I know that this 60 plus this angle has to equal 180. So what that tells me then is that this angle has to be 120 degrees. Now, since I know that, then I know 180 plus 2 of the same angle, because those two angles are equal. Sorry, that would be 120 plus the 2x has to equal 180. So we know that 2x is equal to 60, which means x has to be 30 degrees. So that means that z here has to be 30 degrees. So then my last thing is I need to find the value of x. Well, as we know, this also would have to be 4. And remember, our base angles are opposite of our legs. So that means that 4 must equal x plus 1. I subtract my 1 from both, so I know x has to be 3. Okay? And that's how we would go about using the rules of equilateral triangles and isosceles triangles to find the missing sides. Let's try another one. Here we go. We're going to start off, we're going to find x, y, and z. So if we start off, let's kind of go through what do we know and what do we not know. All right, so when we look at these, we know that these two angles are the same. So we're going to start off just marking up what we know. So we know those two angles are the same. We know this 40 degrees and this angle have to add up to 180. So we know that this angle here has to be 140 degrees. So 140 plus 2 x's, because each of those would be x, has to equal 180. I minus, so 2x equals 40. So x must be 20 degrees. So we know that one. So now I know that's 20 degrees. And I know this side is 20 degrees. So now that I know that, then I look and I see that there's a right angle here. So that means this side has to be 70 degrees. So to find the value of y then, what I know is that y would have to be found by taking 70 plus 40 plus y, and that equals 180. So 70 plus 40 is 110, and that equals 180. So therefore, y would equal 70 degrees. Now, what does that mean for me? Well, that means those two angles are the same, which means those two angles are the same. And if we look back, we also know that these two sides are the same. So since those two sides are the same and it's the same as z, then we know z has to be the measure of 18. And notice there we work all the way around using isosceles triangle properties and theorems and equilateral properties and theorems. Okay, and that's how we use those to start off with.